So I was asked a really interesting question the other day, and that is, how is it that you evaluate the limit as x approaches infinity for sine of x over x? And this is not one of those conventional limits where it is that we can use L'Hopital's rule in order to evaluate it, because L'Hopital's rule implies that we would have an indeterminate form of the form infinity over infinity or 0 over 0. Now the issue over here is that if x were to grow larger and larger and larger, the denominator is going to grow to infinity. However, the numerator is not going to grow to infinity because the sign is constantly oscillating up and down between -1 and +1. So because of that, it's not an infinity over infinity or a 0 over 0 kind of situation. So what we'll do in order to evaluate this limit is find two functions, one that's going to be constantly less than this function and one that's constantly greater than this function. And if we can evaluate the limit of those two functions, and we know that this one is going to be squeezed in between them, then we know that the limit of this one will also be the same as those two. So one thing that we know about the sign is that it constantly oscillates back and forth between -1 and +1. So what we can do is we can try to squeeze this function in between -1 over x and +1 over x, seeing as we know that this function will always be greater than or equal to -1 or less than or equal to +1. So we can write this down as -1 over x will always be less than or equal to sine of x over x, which is going to be less than or equal to 1 over x. Now these are limits that we know how to evaluate. If we tried to take the limit as x approaches infinity for both this one and this one, we would be able to. Take the limit as x approaches infinity for -1 over x. As x grows larger and larger and larger, this function will tend towards 0. Take the limit as x approaches infinity for the one on the other side. The limit as x approaches infinity for 1 over x is equal to 0. And because we know that this function is constantly caught in between this function and this function, then by the squeeze theorem, the limit as x approaches infinity for this function is also 0.